Hi, we have the solar panel here. They're going to be sitting around to elementary schools. Johnson Mello donated this really nice solar panel for us, and a lot of the folks, Todd Hendricks and Matt and JD from operations, have helped us put this whole thing together. Let's take a closer look. So, this is the backside where all the brains are for the solar panel. We have DC direct current voltage coming in about 18 volts through these wires into this solar panel switch. I got two switches here. We can turn the panel on and off, and if we turn it on, it sends the power from the panel, from the sun, into our solar charge controller. Once it's in the controller, it sends it back through this switch to our battery. This is how we store the power we can use later in the day or that night. So solar panel, through a switch, through a controller, back to the battery. It's all DC battery power. From the battery, we can come back now to the controller, and this is what's like the brains of the whole thing. It can send it out. So it sends it out from the controller over to the DC side. We have another monitor that monitors all the batteries, and then it goes to our inverter. Now, an inverter changes DC back to AC, alternating current, just like you have in your house or in your classroom, where you can plug things in. So this is basically taking solar power, battery power, back to AC power. But we have something kind of interesting. We can start monitoring and measuring the volts, and that's where these guys come in. This is our probe that's hooked up, goes back into our computer where we can collect data. Let me show you all these one by one. So let's take a closer look. So this is the back of the panel right here, and this is where all the volts come in. And there's a thing called a diode, and that's nothing more than a switch that lets the energy go one direction. It comes on down through these cables and into our two switches. This switch is the solar panel switch. This turns the panel on and off, and we can follow that on down to the controller. And as you can see right now, we got 13.2 volts coming into the controller. And since it's a controller, we can send it back out up through this switch, which is right here, which is the battery. You turn the battery on and off. Here's our battery, or our storage, both day and night. And we have a little safety fuse right there in case things get too overheated. So now we come back to the controller, and we come back down, back to the controller. And now from the controller, we can go right here to our solar DC volts. We attach the probes here. These probes measure volts, and it's hooked, it's a 30 volt voltage probe, and then it has this little component right here, which is the Go link. And the Go link goes right into a program called Inverter Graphical Analysis. Now, if you have a Chromebook, that's just a free extension. If you have a laptop like I'm using, you have to download the program. It's free to collect the data, and it's real simple: start, stop, data collection. So this is the solar DC side, but let's go back up here, and we have a monitor showing what's going on in the battery. So right now, the battery is putting out 13.3 volts, 0.5 amps, and even measured in watts. That's the output. And we got some terminals here if you want to do something with DC, do some more experiments, all on the DC side. We thought, you know what, let's go and turn this back to something we can use. So installed an inverter, and this inverts the DC back to AC. And it's got a little fan on it, USB ports, and 110 volts. And with this, we can do a lot more experiments, like hooking up an LED light or a computer. So the whole point is to see how we can take solar power, turn it into storage, and then use it.
Hey, I'm going to use this real quick. Is that all right?
Yeah, what are you using it for?
I got to charge my phone.
Sure, why not? That's what it's for.